Hello everyone, this is a follow-up video or continuation of the previous video in which I explained how do we derive an interval that represents a sequence of symbols that we're trying to communicate. So in the previous video, we found that A0, A2, 1, A1, A3, according to that distribution, is represented by this interval. In that video, I'm going to show you how do we find a binary sequence that fits within that interval. So the process starts with dividing the space between 0 and 1 into 2 bits from 0 to half. We assign the binary bit 0 and the bit 1 to the space from half to 1. So basically this is just one bit and it's off here and on here. And this is the boundary. You have to figure out the boundaries between these compartments. So this boundary is a half, and this is 1, this is 0. So the interval we're trying to represent is 0.4408, 0.44213, and obviously it belongs to this compartment, but it does not, this 0 bit does not fit completely within that interval. So what we're going to do is to add additional bits, and hopefully there comes a point where the binary sequence or the bits will fit completely within that interval. So this is the vision behind what we're doing here. So add additional bit. So we're going to add additional bit in this lower compartment. It's going to be off, and in the upper compartment it's going to be on. So here 0 and here 1, and then we're going to figure out the coordinates of these boundaries. So the first bit represents half, the second one is 1/4, the third one is 1/8, and 1/16, and so on. If it's on, you multiply by 1, if it's off, you multiply by 0, and then you add the numbers to figure out the binary expansion. So if you did the calculations here, you'll figure out this is half, and this is halfway, so this must be quarter, and the calculations affirm that. So this is quarter, and this is 1/2. So this interval is still between 1/4 and 1/2. So then 0, 1 does not fit completely within this interval. So then you'll need to subdivide this binary chunk into 2 compartments. So 0, 1, you add additional bit, and then you turn it off here and then on here. So 0, 1, 0, 0, 1, 1, and then figure out the coordinates. And here I go through the example of showing you the lower boundary and the upper boundary. So 0 multiplied by half, 1 multiplied by 1/4, 0 multiplied by 1/8, that's 1/4. And then here, 0 multiplied by 1/2, 1 multiplied by 1/4, 1 multiplied by 1/8, that gives you 0.375, and the top boundary is 1/2. So if you calculate this, you'll realize that our interval is still within that, within this binary chunk, but it doesn't completely fit within it. So you'll continue this process of adding bits and calculating the boundaries and keep refining these compartments until you find a binary sequence that fits within that interval, that lives inside that interval. And if you have patience, this is the binary sequence that you'll arrive at after, I think, almost 11 steps, and the details are in the paper. So check it out, and if you have any questions, let me know. Thank you.